Moving on now to destruction. So obviously you need to check out the destruction courses for a full rundown on that, because this is a whole nother topic in itself. However, what we will notice when we take a look at the cinema versions of explosions is that cinema loves debris. And most likely, if you're getting hired to make a large explosion of some kind, half of what the client really wants is a bunch of debris. So take a look at this upcoming scene. Notice how much debris is taking up your field of view here. It's going to be a lot. So he goes through, fires, bam! Look at that. Let's see if we could skip back a tad bit. So look at how much debris that is. That's taking up almost half of what we actually see here. And so if you want to add a lot of realism to your explosions, you have to add a lot of realism to the RBD simulations, to the debris, to the stuff that's flying in the air. That's really what adds a lot of detail. And this also helps with scale quite a bit as well. Really, you want to know that the secret to cinema magic is motion blur, lots of debris, and clipping out your highlights. That's one thing that ILM has taught us. But yeah, I mean, there you go. Huge explosion because it took up the whole screen. And well, my point is, debris is a central part to this whole workflow. I'm going to give you guys an overview of how to spawn debris from the ground. But beyond that, you'll need to make a separate study out of destruction. In the real world, we see that debris can also potentially be a source for fire. Usually if the debris is flying through the air, it's on fire, it's not creating a lot of smoke. That's one thing that people make the mistake of all the time. These bits of debris here aren't really causing the smoke. If anything, they're going to advect smoke. So I also want to point that out. Usually if you have debris flying around, you just set it on fire like this, and that's more realistic. So in the real world, by contrast, we usually don't see a ton of debris, that being the exception. It all depends on the environment, obviously, but we don't see any debris right here. So just be sure to look at reference, be sure to look at what your client is trying to do. We will have some debris kind of flying out of the bottom like that, but it just depends. If we hit like a grassy field, look at the shape of the debris right here. A lot of kind of stringy, strandy looking stuff. So again, keep in mind the environment. That determines what you're going to do for this RBD workflow. And oftentimes you'll probably want to exaggerate what the environment might do. In Houdini, let me give you guys an overview of what's happening, and then I'll get into the part that's a bit more complicated. On the left here, I have rocks. This was something I brought in from Megascans. And so we have rocks coming in. We have the pyroburst source SOP, and we're taking all the points there and copying the rocks onto those points. If I look in our viewports, what we're trying to get is this. This is going to be the first frame of the rocks advecting through the air. And the nice thing about using the pyroburst source SOP is this gives us velocities which make sense for the explosion. We could try to get velocities from the ground, but it's just a bit more difficult to do as opposed to using the velocities built into this pyroburst source. So that's why I'm using this particular method. There's all kinds of different ways that you can spawn debris. However, in this case, it's just all kind of built in for us, so that's really nice. Anyway, the pyroburst source happens. I clean up some of the attributes right there. The time shift freezes this in time, so I'm freezing this on frame 32, and then I recapture the start frame. For some reason, the pyroburst source doesn't actually keep the start frame. It's even if I try to copy all the attributes, we don't have start frame anymore. And I'll tell you why that's relevant down the road, but anyway, that is captured right there. The velocity multiply, this is a noise. A float noise that I set on the points. And the idea is that we're going to use this attribute to multiply against our velocity and give ourselves a bit of randomization. So that's what's happening there. We're randomizing the scale. I'm using a ramp here so that most rocks are going to be kind of on the smaller size, and then some of them are going to be large in this distribution right here. So that's what's happening with the scale. Remember, scale is in X, Y, and Z. P-scale is in all directions. So I'm doing the same thing with P-scale. And we're randomizing the normal. We're adding a bit of noise to our velocity. This is all stuff you guys have seen. That's why I'm going fast here. We then multiply our velocity against the velocity multiply vector again. With the velocity, it kind of got a bit messy here, but I'm basically just altering these guys in a way that's interesting. So that happens. I'm randomizing an attribute called force. That's going to be useful in how the rocks actually move initially. We have a randomization of our angular velocity. You have to remember that angular velocity exists in degrees. So how many degrees of rotation are going to happen every single second? Right now, we're randomizing that between 100 and 360. So that will spin the rocks, essentially. And finally, we have the variance select, which will select which rocks get attached to which points. Over here on the rock side, we have our rocks. Again, I clean up some attributes so that we just have a material, some normals, UVs. I then pack this. So we middle mouse. We have 5 packed fragments. We then do the whole variant thing again as a point attributes. Variant select. I am randomizing this using a uniform discrete so that we don't have any decimal places. So if you're not familiar with the attribute randomize, do check out the Node Bible entry for that. And we are saying that we would like to basically set that variance right there. That all goes to the copy of the points. There's our rocks, and we're pretty much good to go to get us started with this simulation. Now, if any of that stuff was confusing, then check out the links on the screen. That'll link you to Destruction 1, as well as the copy to points, and earlier when I was talking about the attribute randomize. These are all topics that I've covered in separate lessons. So if any of that was, again, confusing to you, then please refer to those links. Okay, so we have that. We are then adding a name attribute, because something I talk about all the time in destruction is that the name is always going to mess you up at some point or another. This name right now only has 5 unique strings, which means that if I was to put this in a solver, the solver would only see 5 pieces. However, we have 15,000 pieces. So this assemble is recalculating the name so that now we have all of those pieces right there. And that's a primitive attribute. I need this to be a point attribute. The point's still at 5. So good practice is that whenever you establish a name, be sure that it exists as both a point and a primitive attribute. That's what's happening here with this attribute promote. So now both our point and our prim are the same thing, and it's the same number of pieces. Attribute delete for any attributes we don't need anymore. And then for the RBD configure, I have this set to a concrete sandstone. That gives us some mass to work with. And that is about it. One thing that we will do is we will toggle this active attribute. So let's go ahead and set this to manual. Frame 30 is when everything hits. Keyframe that, 0, 31. Let's activate it. So middle mouse here, I believe. And now we should see that the active is an integer that will be read by bullets. So the idea is that, again, we can read in attributes at every single step. In this case, we're going to use this to activate our rocks. Now, if you're using multiple missiles to hit down with the power burst source, then you need to get a bit more creative with the active attribute. You could try to just, keyframe a different version of this for every single missile. Or if you want to do that procedurally, I could show you real fast that we have a soft solver right here, which activates that attribute. So basically, if we take the start frame, set this equal to our current frame, active is 1, And then kind of like we did to establish our start frame, we're using that same sort of logic. So if the active is equal to 0, then go ahead and look at the previous frame right here. So this basically will maintain the active attributes over time. If you want to do that more procedurally, I again find that it's easier to just keyframe this for one explosion for right now. But I just want to show you that off to the side, just in case you're wondering that. Anyway, I take velocity, I adjust it again. This is, just kind of production. It's a little bit messy, but we are just altering velocity a bit more right here. I'm also adding a noise here to velocity. And everything travels on over to the .NET. In the next video, let's talk about this .NET, and I want to get into the more complicated piece of this whole section on how to enact velocity when this thing is active. So we'll check that out in the next video.